Alrighty, so I was able to get this recording to start. So we're gonna go ahead and start with our bell work. Okay, who here was not able to finish their cool down yesterday? Yesterday.
I don't think.
Okay. So I was planning on giving you some work time to do that after our bell work. But I don't think with the issue with the camera, I'm sorry that took up that time.
So is it going to be due tomorrow?
It will be due tomorrow, okay? But if you can get it done today, that's perfect. But I will let you guys turn it in tomorrow, all right? Alrighty, so let's go ahead and answer these bell work questions. We have 2/3 plus 3, 1/2 times 2/3 divided by 2/6, and 1/5 plus 2/1 times 2/3. Okay. So same thing we've been going over, right? We got to think about our orders of operation PEMDAS. There's no parentheses, no exponents, so we got to start with multiplication and division. For this first one, I don't have any multiplication or division, so I just got to go straight forward with addition and subtraction. 2/3 plus 3 would just be 3 2/3, but I want my answer to be in fraction form. So I need to switch my 3 into a fraction with a denominator of 3. Okay, and all whole numbers are technically a fraction over 1. So what do I need to multiply this 3 over 1 by, the top and the numerator and the denominator by, to get to a denominator of 3? 3. So we're going to multiply the bottom by 3, the top by 3. We will have 2/3 plus 9 over 3. Now we have a common denominator, so 2 plus 9 is 11. So we will have 11 over 3. 11 is a prime number, 3 is a prime number. This is the most simplified answer. Okay, next we have 1/2 times 2/3 divided by 2/6. Now looking at this, we have multiplication and division, right? Multiplication and division can happen at the same time. But what we need to do is we need to go from the left to the right. So we're going to start with our multiplication, left to right. All right, I'm going to draw an arrow starting here, going to the right. So we have 1/2 times 2/3. We multiply straight across. You would get 2 over 6. So that would become 2/6 divided by 2 over 6. What's a number divided by itself equal to? 1. So this should actually just be turned up to a single 1. But if we were to do our keep change flip, it would become 2/6 times 6 over 2. And we can see that we can cancel out the 2's and the 6's, right? There's 2 2's, 2 6's, so they all become 1 simplified. So it would become 1 over 1, which is just 1.
I ain't doing that second one.
What's the point of that?
The second one?
That's like 10 times.
That's just to show you that we get the same answer whichever method we do, right? If you do it just how general number divided by itself is 1, we could also do the keep change flip and show that the keep change flip method also works, right?
Will there be times where we have to do the keep change flip method instead?
No. You're rarely going to see where a fraction is divided by itself when we do fraction operations, so you're most likely wanting to do keep change flip. It should have been the other way. When are we going to be able to just simplify like this, right? Pretty rare. Usually there's going to be a fraction divided by a different fraction, so you'll end up having to do the keep change flip. I planned this one to make it look like that because not really doesn't happen much, but I want to still be able to say like, hey, a fraction still divided by itself, it's still just 1. Alrighty, next we have 1/5 plus 2 times 2/3. Gotta do multiplication first. So we have 2 times 2 and 1 times 3, which it will become. So I'm gonna bring my 1/5 forward. My plus, 2 times 2 is 4. 1 times 3 is 3. So we have 1/5 plus 3 or 4/3. We have to get a common denominator. 5 and 3. Don't have one that's pretty close. The only one that we can see is when we multiply them together, which is 15. So it's going to be times 3 on the bottom, times 3 on the top, times 5 on the bottom, times 5 on the top. And this should equal 3 over 15 plus 20 over 15. We have a common denominator now, which is over 15, so we can do 3 plus 20, which is equal to 23 over 15. 23, not divisible by anything 15 is, right? Not 5, not 3, not 1, not 15. So this is our final simplified version. Okay, once you have that, please go ahead and grab your workbook and turn to page 343 for me, please. 343.
Nathan, get my book.
Alright.
Give me a bell, boy. Good. I was waiting for you to say something. You like lag. You're good. You're not good. Like I'm
Okay, again, we should be on page 343. It is on the front board. Oh, you guys cannot see that focus.
Thanks, Dookie.
There you go, 343.
Wait, why don't you get GPD?
Where's mine, bro?
Bro, we're looking
I still need to get the practice done.
You're on, I thought you finished your practice.
I got the Alex assignment done.
So you're on the cool down.
Yeah,
I'm
yes,
sorry.
sir.
Do you have a copy of it?
No.
Okay, I'll get you a copy. Who did not get a copy of the cool down yesterday? Did anybody not get a copy? Kenyon, did you want Cameron, did you get a copy of the cool down yesterday? You did? Sure, did you get a copy of the cool down yesterday? Okay.
No, I'm
Just wanted to make
sure
sure.
on that.
Banished to the corner. You are banished to the
Hey,
corner.
boys.
You little stinky boy.
You have it ready? Yeah.
Don't move.
Alright, hey Chaser, can you get back to your seat, please?
I warned you. I warned you.
You good boy. Turn around, stinky boy.
So if you
I
look
warned
at
you,
that
bro.
first question, it's a what do you notice, what do you wonder? So if you could please do me a favor, go ahead and write out what do you notice about that triangle figure, what do you wonder about that triangle figure? Okay, look at the size, look at the markings, look at the variables. What do they tell you? What do you wonder?
Bro, why did you do that?
Okay, I'll put that on the board real quick. I'm accepting this pass.
There.
Alright, so go ahead and look at that. What do you notice? What do you wonder? Okay. Right here. What do you notice? So I'm going to write my notices on the left. I'm going to write my wonders on the right. I'm going to draw a line down the middle. Okay, I'll give you guys about another minute to go ahead and look at what you notice and what questions you might have.
The eye of Ra.
The Eye of Ra.
Eyeball of prophecy.
Yeah, it is. But he's the eye in the middle. And it has to be 3D.
What do you want to use?
Almost 3D and have like an eye right here.
Yeah.
Oh, but
Fourth all the way to 12.
Okay, another 30 seconds or so.
it's not 3D. Anyway, no, I'm gonna have to do the second little thing with that eye. Wait, isn't it? Like that, I thought that was what I thought was. Yeah, something like that. Yeah. Because Rob is.
Oh, Alrighty.
symbol. Yeah.
So you please refocus to the front. Okay, can anybody tell me one notice that they found here?
Right, it has 4 triangles.
Okay, so thanks,
Five.
Chase. There are 5 triangles in total, right? There are 4 small ones
Yeah.
on the inside.
Yeah.
Brinley,
I put all but one triangle has markings.
right? So if you look at it close, it's there. There's one side for each of the triangles that's missing markings, right?
Well, one.
And then that one triangle in the middle is missing all of its markings. So how do we write that in the notice? Do you want to say some triangles have markings, some
I
don't?
just put all but one triangle because all those sides
'Kay.
make up the triangle.
All but one triangle has congruent markings.
I feel over half of the notebook.
Okay. Are there any other notices? Any other notices?
Their angles look very similar.
Okay, the angles look similar.
This entire year.
I end up breaking that. And that's why I use it.
Okay, anything else? Anything else you guys noticed? What do those tick marks tell us?
This side.
And since if some of them are the same, what do we know is true about those?
They're congruent.
Right, the sides. So we have congruent
If
sides,
you split it down the middle,
right? Do we have enough to do any congruency statement though? No, we would need one more side length to maybe be able to prove that.
if you connected C and M, by the way, both sides would be equal.
If you connected CM,
Both sides would be equal.
what do you mean both sides?
The left and the right side would be equal, like the big triangle.
Mm,
Like all the triangles would be like.
It
yeah.
looks
Split it
like
down the
it's
middle.
tilted this way.
I don't think so, man. Because if you look at the tick marks, the right has one tick mark, two tick mark, two tick mark. So if we split it, the 2 triangles will have different lengths in the end.
Bro!
So it might look like it if you were to do it, but by the markings we have, they would be different. Okay. Yes, Blakely?
I wonder which triangle came first.
Okay,
It was like the big
which
triangle or the big
triangle was first? That's awesome, right? Okay. Does this look like anything we might have seen before, Brinley?
Oh, I was
No,
gonna
go ahead and say what you.
I was, my wonder was are all of the angles congruent?
Okay, are you talking about like corresponding angles?
Yeah, like this one.
Are all corresponding angles congruent? Okay. Okay, and what can we tell about side AN and side CN? What happens with those?
They're equal.
They're equal, right? So we can say that. So line AN is congruent to line CN. What else lines are equal to each other?
MB and A.
BM and AM, right? AM,
And L and AM, right?
A,
BM.
B, and N, L are parallel.
And
AB and NL are parallel? How do you know that?
Cause they go under.
Cause they never got tied.
They don't put.
Right? Can we
Well,
say
wait, no, they
can
aren't.
we say that that's a wonder maybe?
No,
Are they parallel?
They aren't parallel.
They touch at the
They
bottom.
would touch because it's not perfectly congruent if you or perfectly equal if you cut it down the middle, like what we just said. It's tilted, so if it was perfectly, I guess, even on
So-
both sides, once you cut it down the middle.
Let's put that as a wonder. Is NL
But it's tilted. It would never be.
parallel to AB? Right? Chase has an argument that maybe it won't be.
it's
Nathan
tilted.
might have an argument that it might be. We're not too sure though at this moment. That is a good wonder though. Are these lines parallel?
182 degrees.
Okay. Okay, my last wonder that I'm gonna put here is, are the triangles similar?
Yes. I wonder. Oh, I have a wonder. I wonder if the big triangle, like that fits the 4 small triangles. You know what I mean, like CAB.
Uh-huh.
I wonder if those are smaller ones are a dilation of CAB.
Oh, right, we're dealing with dilation. So is there a dilation in play? Right, that is a good question.
Thank you. I know.
Right, because if we knew if there was a dilation in play, let's say C was the center of dilation,
Uh-huh.
and NL was dilated out, wouldn't that kind of make sure that NL and AB were parallel? Right? Because we know that when we do dilation that's not centered on the line, we get parallel lines that are distinct. And we might be able to see that here. That's a good notice, or a good wonder. Alrighty, let's go ahead and we're going to go ahead and flip the page. And this is when we're going to actually be using the extra sheet for you guys. Okay, so what we're going to do is, I knew it was going to be pretty hard for you guys to see how we can split these two triangles, right? Alright, if we split it, we say that triangle ABC is here and that points M and M are the midpoints of the two sides. Right? So let's look at question number 1. It's asking to convince yourself that ABC is a dilation of triangle AMN. What is the center of dilation? What is the scale factor? Okay, so looking at these triangles, can we see how there's a dilation, kind of?
Yeah, NA is the same as CA.
Right?
Same side.
NA is the same size as CA, and AM is the same size as MB. So what is our scale factor for this then?
We don't know.
You can measure it.
Okay, we could measure it. Would you guys want to put numbers onto this to kind of see what it might be?
Can we like just make up a scale factor, please?
We don't need to make up a scale factor because it already has one in here, okay? Okay, we're going to see what that is. So we see that there is a dilation. What would be the center of dilation? Right, so A is the center of dilation.
I'm guessing 2.8, like complete guess.
Okay, what is the scale factor? Okay, so if I think of this, AN, let's go ahead and give AN a psi. What measure do you guys want to do for that? What do you guys want to do, 3?
Why?
I'm just picking a number.
I'm so excited about 3.
I'm just picking a number, sir.
Can we make it double
Are
digits?
doing
Like,
inches or
can we make it like
Let's not worry about units either. We're just putting a number here.
39?
I say 72.
Let's work with
Actually,
smaller
84.
numbers,
Okay,
single
seven.
digits,
84.
single digit
Seven.
numbers.
7.
Oh yeah,
All right,
like 8.
7 or 8, 7 or 8.
7.
7.
7.
Magic.
All right,
Yeah,
we'll
people in the middle side
do
of the board.
7 and 8. How about that? Let's make this side A and 7, and let's make this AM side 8. Okay.
I just want to see the base.
So if AN is 7, how much is NC?
Well, depending. Oh, 7.
7. Okay, if AM is 8, what does MB equal to?
8.
8 as well.
Wait, NC. Which NC? I don't see it's on the paper.
NC is right here
Bruh.
on this top
Wait,
right.
I gotta do it over here.
Yeah, sorry, we're on page 344.
Well,
Okay,
I was
300.
using this paper at first.
Yeah, you can do that one as well. That's
There's
perfectly
no,
fine.
There's no NC.
Right, there's no NC on the big triangle. Okay, that's where we are wanting to get to, right? So if I reimagine or put my distances here, AN is 7, AM is 8, right? But what's the full distance of AC?
14.
14, right? Because we have a 7 plus a 7. And what's the full distance
So,
of
wait, wouldn't the
AB?
scale factor be 2?
16.
It would be half because I was going from the bigger to the smaller.
So if you go from the bigger to the smaller, it'd be half. And Chase, if you go from the smaller to the bigger, it would be
2.
okay. So
So we're both right.
you guys are both right? So we have two options. We can do
I say.
right 7 over 14 or 14 over 7.
I say small.
Right? Those are the sides that we compare, the AN and the AC. Right? And then the other side would be 8 over 16 or 16 over 8. Right? But if we look at it, it says triangle ABC is a dilation of AMN. So we're going from AMN to ABC. So are we increasing or decreasing? So what does our scale factor have to be bigger than? Than 1. So which one of these are bigger than 1? Is 8 over 16 bigger than 1? So it's not that one. And is 17 over 14 bigger than 1?
You mean 7 over 14?
I mean 7 over 14, my fault. 7 over 14. No. So our two scale factors are 14 over 7 or 16 over 8, which are equal to 2, right? Right, so how do we find our scale factor? We take the image distance, we put it over the original distance, right? Our image distance was either our 14 or a 16, so I'll put 16 here. Our original distance was 8, and we simplified that to 2 over 1, right, which is equal to 2. And same thing over here, right? We did 14 over 7, which is equal to 2 over 1, which is equal to 2. Okay, so whenever we're trying to find our scale factors, we take the distance of what we dilated and put it over our original. Okay? This cuts out the need to know both of the scale factors or both possibilities, but you can always revert back to that and be like, hey, am I growing or am I shrinking? Does it need to be greater than 1? Does it need to be smaller than 1? Okay. So, let's say that our original, hope you guys can see that, sorry. All right, let's say that our original triangle is AMN, right? And we were to have these sides. So I'm going to go ahead and sketch my triangles again. All right, we have A and M. We have a 7 and an 8, right? What is 7 plus 8?
I forgot. 15.
15. So it needs to be at least. So let's make this side equal to 16. All right, let's make side NM equal to 16.
Because it has to be greater than 1.
Okay. Now if I were to go back over here, right? So I made this 16. Our scale factor was equal to 2. So what would that mean my longer side would have to be?
32.
32 as well, right? Because 16 times 2, right? 16 times our scale factor 2 is equal to 32. Okay, so this is a dilation. And remember, N and M were midpoints, right? And what is now true about the line NM and the line CB? Since we have a dilation.
NM is 1/2 of CB.
Perfect. NM, let's go ahead and write that right here. NM is equal to 1/2 of CB. Or 2 of NM is equal to 1 CB. That's very interesting, right? So when we have the mid-segments, right, the midpoints combined, right, so our midpoints combined by a line, this is the mid-segment, right? The mid-segment of a triangle is half of my corresponding side. Okay, that is a very interesting thing to see. Half of my other side. Okay, and what else is true about these two since we have a dilation, right? When we dilate lines that are not centered at, that don't go through the center of dilation, what type of lines do we get? Right, our center of our dilation was here.
Congruent.
Going out, we get parallel lines. So these lines are actually parallel as well.
Aren't they also congruent?
Write that down for me, sir, okay? You said what?
Aren't they also congruent though?
They are congruent, right? Because we just said that the smaller one is half of the longer one. So they're similar, right, in a way, but they're not congruent. Yes, sir.
Writing test tomorrow.
Oh, this whole time, man?
Yeah.
Dang.
Can't interrupt the lesson now.
Alrighty.
Kids nowadays.
So, this is what is important to know about that. Alright, our side lengths should always measure and simplify to our scale factor, right? If we do our image over our original, we get our scale factor. Image over original, we get our scale factor. Okay, and we're going to actually end up using this idea of image over original equaling our scale factor to show how we solve for missing sides. But that won't be until our next lesson. So please do me a favor, go ahead and turn your page now.
346.
346, right? And now it is these bottom two triangles that we have right here. Alright, so we should have these bottom two triangles.
We don't need to flip it. It's 345, I think.
Oh, my fault. It's 345. I lied to you guys. You don't need to turn the page. Thanks for letting me know. Okay, so it says here, triangle ABC, M is 2/3 of the way from A to B. So A to B would be 1, M would be 2/3. Okay, A to N is 2/3 of our distance AC. Right? So, are these a dilation? Okay, what would be our center?
A.
Good. So our center of dilation is A. Right? And our scale factor is getting smaller, right? What is our scale factor? 2/3. It tells us that the distances of M is 2/3 of the full, and 2/3 of CA is where our N is at. Okay, so this is where our 2/3 comes from. Okay, so we are now able to show that we have some cool stuff here. So we have a dilation, right? So what do we know about this angle right here and this angle right here?
That M is 2/3. No, wait. They're the same.
Right, yes, they are the same. So we can say that angle B is congruent to angle M.
That means angle N is congruent to angle C too.
Perfect. Angle N is congruent to angle C. Okay. And now that we know that we have two sides or two angles already congruent, what can we assume about the third pair of angles?
What'd you ask?
Right?
What?
So now that we know that these two pair of angles are congruent, what can we say about the third angle automatically?
That's right, it's going to be congruent.
It's going to be congruent as well, right? You guys remember that theorem from a little bit of a while ago, our last unit? Triangle congruent. It's talking about the third angle.
HLR.
No, that's for
Yeah,
congruency
congruent
times.
parts are congruent angles are congruent and
Not CPCTC. It's even before that. Even before that. So if we knew that two pairs of angles were congruent for one triangle and a second triangle, what do we know automatically about that third pair of angles?
Like vertical, where they're like.
Not
one is
vertical.
That's nice.
Okay. This is called the third angle theorem.
Oh, yeah,
Bro, so you bring out things that was like 6 months ago. I
Right.
remember that.
The third angle theorem tells us that if we know two triangles or two angles are congruent, then the third automatically has to be. But we can also think about it like this. Isn't our third angle A for the smaller triangle? And isn't our third angle A also for the bigger triangle?
Yeah.
So since we technically moved the smaller triangle away from the A on our paper, if we move it back on top, shouldn't those be the exact same?
Yeah.
So yes. So our last angle is going to be the angle that is overlapping. Okay, this is very similar to the reflexive property, right? It's the same angle when they're on top of each other, so that angle needs to be similar no matter what. So our angle A is congruent to our angle A. Okay, So this is actually one way we can tell we have similar triangles, right? This is called angle-angle similarity.
Bruh.
Okay, please highlight this, star this, do what you would like. Okay, angle-angle similarity. Okay, this tells us that if we have two triangles, right, if we have two triangles that have two congruent angles, then that means that they automatically have to be similar triangles. Okay, they could be congruent triangles. We would just have to know if the sides matched, right? But we know for sure that if we have at least two angles, they have to be similar triangles. All right, so at least two corresponding angles are congruent, then the two triangles are similar. Okay, that is the AA similarity. If at least two corresponding angles are congruent, then the two triangles are similar. So this is angle-angle triangle similarity. Okay.
Bro.
So sorry about that. I forgot to put the word triangle. This is only for triangles. This is not for quadrilaterals. This is not for many-sided shaped polygons. Okay, for triangles only. Okay, and now since we know that these two angles have to be congruent, we can say that triangle AMN is similar to triangle ABC. Right? And what has to be true about the segment MN and the segment BC? What has to be true about those two segments? What about has to be true about MN and BC? Since we have a dilation, it's not going to be half. What was our scale factor? 2/3. So MN is equal to 2/3 of BC, right? Okay, and what else is true? Will these lines ever meet if we extend them out? No, so that means that they are also parallel. So MN, line MN, is parallel to line BC. Okay, if we think about it, right, these
2-minute warning.
2 minutes.
These are an F highlight, which are corresponding angles.
I'm not sure about one.
Okay,
I think two.
we will finish these notes tomorrow. Okay, shouldn't be too bad. And then on tomorrow, you should have enough time to finish your practice and cool down. Thank you for a good day of notes.
You're welcome.